negligence.
Okay, so we often label it that way, right?
Right, but like,
let's just think about what are the mechanics? What are the mechanics of doctors killing people?
incorrect dosage.
I'm not down on
There's
doctors.
literally so many ways.
But let's just think about what are the
Misdiagnosis.
I gotta get rid of my double talk here.
I think I read somewhere, not sure if it's true or not, but like bad handwriting by doctors kills like a few thousand people each year.
I believe that. And so what bad handwriting does is it allows someone to misinterpret the diagnosis or someone to misinterpret the treatment that the doctor ordered, right? That's what we assume bad handwriting would cause.
Yeah. Yep.
So what are the mechanisms of doctors killing people?
Through indirect or direct action. So like not treating something or treating
I
something.
think more specifically, let's just use our imagination or any stories that we've heard, but right. So prescribe the wrong medication.
The whole thing with how Michael Jackson died.
Oh, I didn't know there was a thing about how he died.
Yeah, the doctor, like, I forget exactly what he did, but he did something with anesthetics.
Yeah. So
Did you just prescribe pills that
do
conflicted with
the
each
wrong
other?
thing, make a mistake during surgery, nick an artery, something like that. But in general, doctors kill people one at a time, right? I mean, they kill a lot of people, but I'm not willing to say that they don't save more than they kill. Doctors a good profession, right? They typically want to save people. And I think a lot of the people that may die because a doctor made a mistake maybe wouldn't have lived as long if there hadn't been a doctor in the first place. But doctors tend to kill people one at a time, right?
Right.
Individual mistakes, individual patient, each case is kind of unique. How do engineers kill people?
By bridge collapsing.
In mass.
Building a faulty product.
You guys don't have audio, do you?
Nope.
We can kind of hear it.
Mike? Can you hear the audio?
Yeah. Is this Vietnam?
Yeah, the guy's gonna start talking in a minute.
In 1968, at the height of the war in Vietnam, 14,000 Americans were killed and 46,000 were wounded. That same year, another 14,000 Americans were killed. But those lives were lost right here in the United States because those American men and women were killed at work, on the job. Another 2.5 million American workers suffered disabling injuries. That's 54 times the number of people we had wounded in Vietnam that year.
What do you think we did? So that's pretty outrageous. That's pretty outrageous, huh? Those statistics.
That's mind-boggling considering the fact how bad Vietnam was.
So what should our response be to that?
Fix it. Like, figure out how we let this happen. What?
Does anybody know what happened?
Did we
After
make
that?
OSHA?
So because of that statistic, because of 2.5 million American workers injured at work in 1968, 14,000 killed at work in 1968. That outrages a lot of people. And so Congress actually enacted OSHA. I think if we keep playing this video for a bit, it'll tell us the exact year. But I think it was 1970, 1971 that OSHA started. Anybody know what OSHA is?
They're like the people who set like the standards of safety around the workplace.
Isn't it Occupational Safety Hazard Association or something like that?
I think it's agency, not association, but I think you got the letters right for the rest of the acronym. So that's the Occupational Safety and Health Administration. Health and safety sounds like easier to say though, huh? I don't know. They decided to, Congress can't think of good acronyms, I suppose. OSHA. Or maybe that's because they wanted it to be an acronym. So they're basically the workplace safety police. I think it was Sam said that they make rules and regulations, and they do that. But they also make sure that companies are enforcing and following both the OSHA required rules and regulations, but any rules and regulations that the company has published. Is this a good thing or a bad thing?
It's a good thing. But like, I feel like there's this whole like atmosphere around, oh, you know, this is totally an OSHA violation, but we're doing it anyway, which I don't know.
So has anybody
to.
ever had a summer job or an internship or anything where they had an interaction or an encounter with anybody from OSHA? Anybody ever worked for a construction company?
We had OSHA all the time on the ship.
You had OSHA all the time on the ship.
Oh yeah.
OSHA inspectors or just people enforcing OSHA guidelines?
No, it was just surprise inspections to ensure that we're following like reactor safeguard controls and standards.
Anybody else?
I interned at a machine manufacturing shop, and I was in the industrial engineering department, so we had a lot of OSHA guidelines to follow and ensure that people were following.
What were some examples of stuff in the guidelines that you remember?
It was mostly safety protocols, especially with assembly lines and the layout of the building, like having a lot of like, you know, tape on the ground where things are supposed to go and stuff, so they don't like get like obstructive in people's paths.
Okay, so keep everything clear. And you're doing industrial engineering, you said?
Yeah.
That's pretty cool. So you're responsible for basically controlling the flow of people and materials through the workspace.
Yeah, pretty much.
Right. Okay. That's cool. Anybody else? Nobody worked construction and heard or had to deal with OSHA? All through high school and college.
Inside for a year.
What's that?
I said I've been trapped inside for a year, so.
You've been trapped inside for a year. Yeah, but just 1 year. Oh.
A year ago, I was in high school.
That's true. Okay, that's fair. All through high school and college, I worked construction, and I remember OSHA. The guys on the crew, the people on the crew of the construction company, did not really see OSHA as our friends, as our assets. I think it's sad that happened, but very frequent. Well, one time I was one of the companies I worked for one summer. The day that I started that summer. The day before, they had gotten a $10,000 fine from OSHA before the OSHA inspector got out of his car when he drove on the site. So when he was sitting in the parking lot outside the little construction trailer, he looked out the window and he saw somebody riding up out of the hole in the bucket of a backhoe. So they dug a hole with the backhoe, and then one of the guys didn't want to climb out. He rode up out of the hole in the bucket of the backhoe. There was several things wrong with that. One, you can't ride in the bucket of a backhoe. It's just against the rules, and it's stupid. Two, the hole wasn't big enough and didn't have the correct shoring to have a person inside it anyway. So he never should have been in the hole, and he shouldn't have ridden up out of the hole in the backhoe. I remember later that summer, we had a crane. They would lift stuff. We were building a bridge across a river, and so it's easy to move stuff around with a crane. And we had a crane with a basket that you'd hook on the little hook of the crane. You could put tools and material in the little basket, and you could move it up onto the bridge or down onto the work site underneath. But sometimes you needed to work on the outside edge of the bridge. And so what we did is we built some handrails on our little basket, and then we would stand on the little basket and hang underneath the cable of the crane to work on the outside of the bridge sometimes. Was that okay?
That just sounds like a bad idea.
No.
So I didn't have any trouble doing it. I was 20 years old, something like that. I didn't have any trouble with it. All the guys in the work site didn't have any trouble with it. We all thought it was fine. But here's what I know. Later on that summer, when we were getting ready to use that basket, got a call on the radio from the foreman, and the foreman says, "Hey, knock the handrails off the man basket. OSHA's on site." So they would have been shut down if the OSHA inspector had seen that. And so employees very often do things to subvert that OSHA inspection. And I don't know if it's because the employees are afraid of losing their job if they don't do whatever it is the boss says, or if it's because, well, we're Americans. We don't like people telling us what to do. And if I think it's okay to do it, I'm going to go ahead and do it. But OSHA is there to protect us and to make sure that companies enforce their own safety rules. And so I guess if I want to do anything with telling those stories, because it's clearly 2020 hindsight, all those things are stupid, right?
Yes.
I mean, it's pretty clear. But people make stupid decisions all of the time, which is why we have rules and regulations to give us guidance to figure things like that out. So if you've ever been tempted to cheat on an OSHA inspection or to subvert an OSHA inspection, don't do it. And often you can call OSHA and you can ask for a voluntary inspection, and they will tell you the things you need to fix, and they won't fine you because you asked them for their help, as long as you don't have too many blatant things. 2 more comments on OSHA, and then we're going to move on. But if 5 people go to the hospital from an incident, or 1 or more people die, 5 people or more go to the hospital, or 1 or more people die from an incident, the company must report the incident to OSHA within 24 hours. Failure to do so is a felony. So they take death and mass hospitalizations pretty seriously. I asked a question in a meeting with the head of OSHA enforcement for Massachusetts, and a whole bunch of other college educators were at the meeting. And I asked the question because we were talking about lab safety, and I run a lab that is potentially dangerous. I asked him, I said, so what if it was 3 students and 2 employees who went to the hospital? Do I have to report it? What do you guys think the answer is?
Yes.
I mean, morally, yes, but legally, no.
Anybody else?
Are all the students of age or are some minors?
Doesn't matter.
Probably
If they're
yes.
minors, there might be different rules, but that doesn't affect the OSHA regulation.
I mean, the student technically doesn't work there, so maybe no.
Exactly. You guys as students are not covered under OSHA regulations. As if you happen to be a PLA or a work study, you are covered under OSHA regulations when you're doing your job. But OSHA is about protecting the workplace. It's not, and I just bring that up. Now, of course, we'd be open to all kinds of other liability issues if we didn't treat students with at least the same standard that we treat employees. And we design everything in order to try to be in excess of OSHA requirements and standards as to safety. And so let's talk about designing things for safety. I think if I click the button here, it's going to advance the slide. Maybe not. Oop, all right, now I can advance the slide. So I said that this lecture is about designing safety systems. What is a safety system? I'm going to go ahead and take some notes while you guys talk. What's a safety system?
like a fail safe, so like the emergency stop.
So fail-safe has a very specific meaning. But you said like the emergency stop. What's a safety system?
Like fire extinguisher.
Like preventative measures or protocols.
I don't know how to spell protocol. That looks pretty good. So what does safety mean? So if we have a safety system, so safety and system are keys to understanding what a safety system is, right? So what's safety?
Maintaining the well-being of the user and people around it.
Boeing.
Somebody just say Boeing.
It autocorrected being to Boeing when I spelled it wrong. Maintain the well-being of the users and okay. I kind of like that definition. So that's sort of the function of a safety system. Does it have to be just the users and the people around it? Anybody live in a WPI dormitory?
Yes.
Yep.
So the building you live in then has smoke alarms?
Mm-hmm.
Has they gone off since you lived there?
Yes.
Not where I am.
Not
Yeah. The building also has a sprinkler system. You see those, right? You're supposed to not hang your hangers from the sprinkler heads and stuff like that. No pull-ups from the sprinkler pipes. Are they both part of a safety system?
Yes.
Yep.
What's the purpose of the smoke detectors?
To wake
alert
you up
you
at
and
3 a.m. for no
To
reason.
detect smoke.
They detect smoke, so that's their mechanism of operation, but why bother to have them as part of the safety
Because
system?
if there's
Warn
smoke,
people
there
to
might be a
evacuate.
fire.
To tell people the presence of smoke, the purpose of the smoke detectors, according to the National Fire Protection Association, is to protect the people in the space. Smoke detectors warn people so that people can leave the space. What's the purpose of the sprinklers?
To suppress the fire so it doesn't spread before the fire department gets there.
Main purpose of the sprinklers is to protect the building, to protect the structure of the building. Smoke detectors should get the people out. The sprinklers should help put the fire out. Years ago, I used to own a bunch of 3-family houses around Worcester and rent them to WPI students. And I actually took a class in building fire safety here at WPI in fire protection engineering. And as my final project for the class, I wanted to figure out, to increase the safety of my property, I wanted to install sprinkler systems in all my 3-family houses. And so at least I did the project about it. So I got a quote from the licensed contractor who could put those in there. And then I called my insurance company to ask how much my insurance rates would go down if I installed sprinkler systems, because I'm trying to do this ROI calculation like we talked about yesterday. And the insurance agent laughed. Why did he laugh?
Because pipes freeze.
Because the insurance probably go up because the reason you install.
Yeah, if I installed the sprinkler system in my 3-family houses, the insurance rates were going to go up because they were more worried about water damage than they were about fire.
I wonder if it would have gone up if you're in California where pipes don't freeze.
It depends on a lot of things, but it probably also depended on my insurance company. But so a safety system is there to maintain the well-being of the users and the people around it, and or the equipment And would you guys agree that this is a good purpose for a safety system? Maintain the well-being of users, people around it, and the equipment and structures, and/or the equipment and structures. I mean, I suppose your safety system shouldn't damage the people to save the structure. But we get all these other words, though. Like fail-safe, emergency stop, fire extinguisher, preventative measures and protocols. What are those examples of?
They're examples of safety systems.
Are there examples either of safety systems or components of safety systems? And so either a safety system in itself or a subset or subcomponent of a safety system. Now, if we want to design a safety system, yeah, I'm going to skip over that. All right, so I should really change the order of these slides. Where do we find safety systems?
Pretty much everywhere.
Pretty much everywhere, all around us. The streets, the highways, I mean, sidewalks are part of a safety system, right? Separate pedestrians from traffic. So we find safety systems everywhere. Why do we need safety systems?
To decrease the risk of injury or death.
All right, so we want to decrease the risk of injury or death.
And protect buildings.
And protect buildings. So we want to preserve capital. We want to not kill people or hurt them.
Also reduce the severity of injuries when they happen.
Reduce the severity of injuries when they happen. Okay. Now, couldn't we just say most of the stuff that goes into safety systems is common sense?
Yes, but then again, we are Americans.
You'd be surprised.
I probably wouldn't be surprised. You know, we have cameras in the shop. Oh, maybe you don't. No, we have cameras in the shop, but we do. So a lot of what we talk about when we talk about safety systems is common sense. And we put securities in to make sure that we use our common sense all the time. In my experience here at WPI, the people who have been injured working in the machine shop have been the most experienced users, not the novices, and they've always been taking a shortcut when they got hurt. And so we put safety systems in often to protect us from ourselves. There's so I don't know if you guys have heard the news about this. This happened way back 2011. How old were you guys in 2011?
11.
11. Wow. So you probably weren't reading the newspaper or seeing the news about this. This is a Yale student who was killed in a machine shop accident. And I remember very well the morning after it happened. I was on my way to work and I got a phone call from the department head. And so the news had gone around the heads of universities very quickly, as bad news like this usually does. And so he explained to me what he knew about it. And he says, "How do we know this can't happen at WPI?" Which seems like a reasonable question. And I said, well, you know, it could happen at WPI, but we have really good policies. So therefore it shouldn't happen here. And you know, since I'm in charge of the safe operation of the facility, I was a little bit defensive with my answer here because, well, one, I was shocked because knowing that it could happen and then having an example of it happening are not the same thing, right? We all know that. And as I thought about it throughout the day, I also said that they're not idiots at Yale. I bet you they have good policies at Yale too. So I had to ask the next question is, how do we know that people follow the policies? Right? Because a lot of what goes into a safety system is establishing policies and procedures for the safe operation of things. And go ahead.
So that's why it's like we have that Google form with the checklist.
So we actually had the checklist before this. The checklist I designed to protect the machines. If you look at the operator safety checklist, it doesn't talk about your personal safety as the operator. It talks about keeping you from doing things that will break the machine tool. But it is why we have those scissors on the side of all the machines with the graphic sign. Do I have a picture of that here? Oh, I don't have a picture of that here. That's very sad. But if you've been in the lab, you've seen that. The scissors are there as a direct result of this accident. So usually when you get your hair cut in a lathe, you die from trauma. So usually it scalps you and you die from the trauma of that happening. But that didn't happen. This wasn't a very high powered lathe. Her hair got stuck in the lathe and it wrapped around and the lathe motor stalled, or the lathe spindle stalled. And she choked to death with her head around the bar of the thing that she was cutting. She was in the lab by herself, 2 o'clock in the morning, trying to finish up a class project. So she was violating all kinds of rules, but that doesn't matter. If she'd been able to reach a pair of scissors, she might have been able to cut herself free. Certainly if somebody had been there with her and they'd had a pair of those scissors, they could have cut her free. So, so the addition of those next to all the rotating equipment we have in the lab is a direct result of this. We had another incident that happened in our lab where you have to have 2 people in the lab in order to work here. And what if you have 2 people in the lab and one of them leaves? Do you still have 2 people in the lab?
Nope.
And so, so we also have a policy that says when you're using unguarded equipment, you have to have had a conversation with that second person so that they know that they are your second person. So sorry, not unguarded, but non-interlocked equipment. Difference between guards and interlocks. We got a very short time left here because I was late. But let's just quickly talk about what do you do to design a safety system? So we can understand the purpose of the safety system, right? We all agree that we need them both to protect us from the equipment and to protect us from making mistakes. So what does a safety system have to do? If you want to design one, what do you have to know in advance? Similar to designing anything else.
You have to know what could go wrong.
You have to know what could go wrong, right? You have to, if you're solving a problem, what's a possible problem? So how could people get hurt in a machine shop?
If something breaks.
So, and if something breaks, typically there'd be flying debris, maybe?
Like shrapnel.
How do you spell debris?
RIS.
Debris. It's spelled like debris.
Yeah. Didn't spell check me. Okay. Entrapment, somebody said. Which I don't think
Crush
anybody's
injuries.
asked this question before. Say again?
Crush injuries.
Crush. What else?
I don't know if it's possible, but maybe fire may start due to machine
Oh,
malfunction.
fire for sure. I have a funny story about that, but we don't have time. How else? So the first thing we do when we're designing is we identify the hazards, right? So these are the hazards: flying debris, getting entrapped in a confined space, getting crushed by something heavy, fire. There's also chemical hazards. So the coolant could be a hazard. There's other chemicals that we use in the lab, acetone, things like that. alcohol, which we use in the lab, sometimes on purpose to light it on fire. So any other hazards you can think of in the lab?
Electrical.
Electrical.
I was gonna say like getting cut or abrasions.
So sharp objects.
Slippery.
Smoke.
Slipping. It's not that easy to add a second column, is it? This is way not as much fun as a whiteboard. Slipping. Somebody said smoke. Smoke. Yeah, I'm gonna put that environmental air. Yeah.
How about burns?
Sort of accidental, but there certainly could be mist in the air, and not just byproducts of fire.
How about burns?
Burns, so thermal. I used to work in a nuclear
noise
power
exposure.
plant. They had to be specific when they labeled a pipe as being hot. They had to say either thermally hot or radioactively hot. We don't have a lot of radiation in the lab. Other than
Yeah, I was gonna say that would be concerning if we did.
There used to be a nuclear reactor in there, right?
The reactor used to be next to us, yeah. So all of these things, how do they hurt people? Maybe not all of them. So slipping, flying debris, crushing, even sharp objects, I'll say. How do those things hurt people?
So flying debris are projectile injuries.
So they'll hurt people by doing work on the body, right?
Yeah, it's creating trauma.
Right. So it's force. It's force applied to an area over time. So it's really impact, right? The crushing could be over a slow time, but if it's enough force, it'll still get you.
Right.
Right. So all right. So how do we keep them from hurting us?
Create a barrier.
By using
a
common
barrier
sense.
between you and the thing. And so the barrier could be a guard, like the steel doors on the lathes, right, with the little tiny window in it. So the reason it's mostly steel and little tiny window is because there's a lot of energy in that workpiece when it comes out of the chuck. How else could we keep it from hurting us?
Safety stop systems.
I couldn't hear you.
Safety stop systems.
Some kind of a system that would stop it.
Yeah.
Yeah. Okay. So the guard doesn't have to just necessarily stop it either. It can also deflect it and make the energy go a different direction. But you want to absorb the energy. You could also have training to keep the people from standing in the path of where it would go if it does fly apart. So training can be a part of that. Flying debris doesn't have to be big to hurt you. It doesn't have to actually have a lot of force if it gets in your eye. So that's why we have safety glasses rules for things like flying debris. So you can identify the hazard, interrupt the path of the hazard to the people. You can train the people. You can give the people personal protective equipment. The other thing we can do to reduce the possibility of the entanglement, entrapment things, or even the flying debris is we can have electrical interlocks on the equipment so that the rotating part, the mechanical part, won't operate if the door's open. And again, that's a way to prevent the injury from happening. So these are all things that we want to consider. Training, warning, stop the hazard, interrupt the propagation. All right, so those are all things that we want to consider when we're thinking about or designing a safety system. I do want to take just a minute. I'm just about to turn on the final exam. Again, it's only 5 points. I'll be live again tomorrow if anybody has questions about that. If you want to come on at 11 o'clock, if you have questions, something you're worried about, I'll do that. We don't have a required topic tomorrow. And I think that's what we have, but I'll be here for questions if you guys have some more questions.
Could we go over some of the past project examples?
Oh yeah, that's right. Thank you for reminding me. All right, I'm gonna turn off the screen share for just a second. I think, did I just turn it off?
Yeah, it's off.
Huh. I accidentally hit the button. That way you won't see everybody's grades when I go look through last term's submissions. All right, Canvas, MPI, courses, more courses. Assignments. Let me see if I can find a good one. All right, without reading all the words on this one, I can see that it got a pretty good grade. Let's see. What if I download it? If I download it, then I can hide the person's name. There, I think I've eliminated all the names. We can just look at it as an example. Screen number 1. All right, so they've got a brief introduction that says what the purpose, what they're doing is. And then they outline some costs here. And so in this one, I actually had people find their own workspace, the place that they were going to do it. He specified the machine tools that he was going to buy. He specified the tooling that he was going to use. He estimated the cost of materials. So I'm not sure what the number of parts here is, because that's $91 is way too much for one piece of that material. And so and I think I gave you part material costs that you could use, so you didn't have to go look them up. But I had these guys look up all these material costs, cost per engine. Oh, that's 6 feet. I got it. And so he divides the 6 feet by the number of parts. See, so I think his material costs are off, because I know for a fact that you can't buy the materials that goes into one of those for $10. But that wasn't the point of the exercise, right? So the point of the exercise was to consider these things and how they add together, so you could figure out a total startup cost. So this would be the amount of money that you needed to get from the from the investors or invest on your own. And I had them do a yearly operating cost. So this is what he thought it was going to cost him to operate for a year. Clearly, he was not going to pay himself. That was one of the options in this assignment, was they didn't have to pay themselves. But it's well organized, it's well laid out. I don't have any questions about what he's doing. And again, I was not a stickler on the accuracy of the numbers. It's more, have you considered the different different costs? And again, their assignment was slightly different from yours, but yeah, in reality, what I want is for it to look like it's well thought out. And I don't expect any two of them to be the same. Did that help?
Yes, that's very helpful. Thank you.
Okay.
Yes, that helped.
Are we able to change how much we charge for the kit?
Yes, if you do, just explain why you decided to do that.
Okay, thank you.
Because again, we just picked that number out of the air based on looking at a couple websites. Anything else?
Can you talk about the final briefly?
I'm guessing it's about 10 questions. I'm gonna double check it, turn it on, but 10 questions worth five points. So half a point per question, similar to the quiz questions. Again, in two tries on the final. If you have a problem, let me know and I can reset it, but it's set for 2 attempts. All right. Well, thank you guys for being here. Again, I will be live again tomorrow, and I'll do it on time for anybody that has questions for the final or anything else.
What link will you be on tomorrow? Is it just the same one as today?
I'll publish a new link. I'll do that when I put the final out.
All right. Thank you.
Okay.
I have a question. We really need the cam files for the other parts. Are those going to go up at any point?
I don't think you really need them with the other stuff that was put in the assignment. I put that stuff there so you wouldn't need the cam files.
Okay, thank you.
Okay. All right. I'll see you guys tomorrow.